Doctori, tutto a post? Welcome back to a new video regarding Sane C++ libraries. So what is Sane C++ libraries? Is this project on GitHub, and it's a set of C++ platform abstraction libraries for macOS, Windows, and Linux. It focuses on fast compile times, being bloat-free, being simple and readable, easy to integrate, and doesn't use anything from the standard C++ library, doesn't use exception and other things like that. And there are no third-party dependencies. So we are using OS APIs. I'm writing, keeping a list of blog posts with the latest and greatest of things that have been added every month. And if you want to be getting in touch, there is a Discord, or you can contact me on Twitter, Mastodon, or even here on the GitHub discussion. So let's go back to what we will be doing today. And why do we have a light team? I don't know. Today I've been waking up, decided to go with the light team, probably because that's one of the few videos that I'm recording when there is a little bit of sunlight, and the dark team was not really working for me today. So today we are light team. So what we will be doing today is actually trying to add something similar to UVQWork of libuv inside the async library. So let's take a look at libuv QWork. Here we are. So basically, this is a very famous Async.io library that is used by Node.js and other projects. So with the QWork, you can do something like that. You can create basically a function that is being executed with, in this case, is this Fibonacci computation. And this function will be executed on a background thread. And then you have an after callback, which is a callback that is invoked on the actual event loop, so that it will be invoked in this case here in the thread that is running main, so the regular main thread, because it's invoked inside the run action of the event loop. So I would like to do something similar, but inside Sane C++ libraries that has an Async.io, a quite comprehensive Async.io library. So where do we even start? The first thing that I would do is getting rid of a problem that was actually existing since we added the ThreadPool. So how does this work inside Sane C++ library? We have when we want to be executing something in a background thread, the user needs to supply a thread pool, which is just a set of threads that you can create, and a series of tasks. This is, for example, what I have been doing in the file operations, because for a number of reasons, file operations cannot be fully asynchronous when you have buffered files, so files that are not open for direct I/O, which are the majority of files that I guess someone will be handling. So this is making the interface a little bit weird to use, because you have to create a thread pool, you have to create a thread pool task, and then you have to create an async file write, for example, an async file write task, and associate the thread pool and the task with the file write task. So all of these is a little bit excessive. Plus I'm using references, so if you try to create arrays of these objects, it will quickly become very difficult. So I want to change this. So the async task, I would like to change it. So that's the first task we will be doing. So I don't want to take any more references to the thread pool and the thread pool task. And I also did this because I didn't want to bring an internal dependency from the thread pool, which is now something that I'm going to do. So let's say we add the thread pool, and in the async task of, in the async task, where is it? Here. So I will replace this reference to a thread pool task to be an actual task. So we will be storing the task needed for the thread pool in this async task that brings together the task, the completion data, and return code, and connects to the async request that is associated with this task. So let me remove those references. I think this is fine. So this now becomes an actual task, and the thread pool needs to become a pointer, I guess. So now I think we have to fix things everywhere. It's not going to be fun. There will be many errors, but we can try. So let's start. Thread pool, now it's a pointer. So every thread pool dot needs to become a thread pool arrow operator. Oh, well, maybe not that one. Let's say I'm fixing this. No matching initialization. This is fine, so we will not need anymore to have a file write task at all. So this means that here, to use the thread pool, we will have to change the start. Yeah, because we will not have the task here anymore. How do I do that? I think this should be changed like this. We remove the parameters from here, and I will create yes, let me create two overloads here. So the user can just set the buffer, the callback, and the file descriptor autonomously, and it will be passing the task. But when passing the task, it will pass also the event loop. Sorry, not the event loop, the thread pool. Thread pool. So you can either call this regularly, just you know, without the thread pool, but if you decide to go with the thread pool, you have to bring in the thread pool and the task, the associated task that has that is where holds the data that will be basically executed on the thread pool. And I need to do the same for the file read. Yes. All right. Yes, I will need to fix all of these. So for now, just delete them. Yeah, comments is something I will be fixing later. This needs to be rewritten actually, but yeah, why not? Well, maybe I can move them. No, I will rewrite them later. Now this ones, I don't need them anymore. Maybe I can just check if this is different than file descriptor invalid. Invalid file descriptor. Yeah, and I can do the same here. And what else? I can remove all of these and all of these. How does it look like? All right, now I need to do, if I'm using the thread pool, I should call the start function that has the thread pool parameter and the passing in the task, and this point by reference. So I need to pass the thread pool and the task. I think this is more clean. Yeah, having a separated, dedicated overload. Now, if I need to set this now. The parameter, the handle, and the buffer needs to be set as field. So file descriptor is handle, and my async file write dot buffer is this thing. And if I'm not using the thread pool, I'll just start the async file write. Sounds good. So this is just buffer. This is just buffer. What am I doing wrong? Oh, I'm not closing the macro. Use of unidentified identifier task. So yeah, maybe let's make two different queue submission. We can do one without the task, and we can do one that has a task and a thread pool. And when we have the thread pool, we can say task dot thread pool is thread pool, and we pass the task in. Let's declare this overload queue submission. Yeah, thread pool, thread pool, and async task unknown type name task. It's called async task. Expected. Oh, even this one is not closed. All right, so this is a protected member, so we need to make it friend struct async request. No matching call, so all of these queue submission with the node PTR can just become submission with the loop. Expected parameter declarator. Here we need to be passing the task, but we don't have the task. So these are the overloads that we will be passing without the task, and we need to create another one where we will be passing the thread pool and the task. And let me add thread pool and task. And I need to do the same for the file write. Oh, this command is even wrong. Yeah, let's fix it. Even this one. Fix the command. All right, so we need a thread pool and a task here, and we can add the thread pool and the task here. Now, oh, there is no async file write task. Oh, I deleted it. Let's add it back. Async write task, yes. Well, the ones we don't need are the read and write task, these ones, because now they are embedded inside async file write task. And the same also here. I can just remove these. Also here, if use thread pool, yeah, let's do this, and we pass, in the case of the, we want to use the thread pool, we pass in the thread pool and the async read task, yes. In the other case, we don't need to pass anything, but before we forget, let's set file descriptor to be handle, yes, handle, and the buffer in which we are doing the file read to be this thing here. Buffer equals buffer, and this is now correct. Oh, we have not been making this public on the read. Yeah, let's make it public. Okay, these are the snippets used for the yes, for the documentation. I can fix also this ones, why not? Yeah, well, I will fix them, you know, documentation stuff is tedious. I will fix them more precisely later, but just for the sake of getting it to compile, let's do it. So this code is not executed. This is just here to go in the documentation. And the same even for this other second snippet of code that goes into the documentation. File descriptor is equals handle, buffer equals right span. So I mean, we are doing always the same thing over and over. So I guess this was not very fun to look at and to watch, but sometimes you need to do it. So does this even work? Let's try. SC test. Let me do if global console we run AsyncTask, report, return 0. Boom, run it. Let's see. It works. So yes, this was just a little bit of refactoring. So what have we done? Let's recap again, just in case it was not clear. I have been embedding the ThreadPool task, which is a data structure holding the function to be executed in the ThreadPool, and the pointer to the ThreadPool and the pointer to the next task that needs to be executed, because they are connected into a linked list. I'm storing the ThreadPool also here because when the AsyncTask is created, the ThreadPool task is still not, let's say, initialized. So its ThreadPool inside will be null PTR. It will become different than null PTR when the task is started on the ThreadPool. So I need to store it also here. And I don't have anymore the need to initialize the async task with a pre-existing ThreadPool task. So this is a lot simpler. And we are ensuring that this is properly initialized just because we are making this protected, and the queue submission function makes sure to set the ThreadPool to the value that must be provided by the user, because we have in the async file write or file read, we are requesting it precisely, or we are not requesting it at all, and the code takes a different code path where async task is null, null PTR, and it will just not be considered at all in all the places, all the relevant places. There are like if statements checking for the presence of the task. So now that we have done this, that I suspect could be even put into a separate commit. So maybe let me stage it. Now I want to do another commit that where we will be creating the actual event loop work. How do we call it? The name that I had in mind is loop work. Let's call it loop work. So this will be loop work object, will be a new type of async, is an async loop work object. Now that we have the loop work, let's create the associated object. Let me take this one as an example. So this is how you create a new async object in the library. So I'm copying the closest one. So the loop wake up, now this becomes loop work. I make a loop work object. The type is loop work without the async. Yes. The completion data is just an empty completion data, and the result is just an empty result because we don't really want to be storing anything here. So this is the completion data, the output of this operation. But as this is just executing a function in a background thread, there is no result. I mean, it will be either, you know, failed or succeeded, because we can make the function to maybe return a result. But yeah, so how do we make the work function? Should I make it maybe returning result like this? Yeah, why not? So I can flag it for failure. Yeah, this looks nice. So this is called on the ThreadPool thread, and this is called after work has been done on the main thread, on the, let's say, event loop thread. So I want to make this to be so you need a thread pool for sure, and you would need a task. But no, I mean, we can store it just here. So we can say async task of AsyncLoopWork completion data is my task. Too many template arguments. How many template arguments? Oh, you just need the async type. Okay. All right, so this object holds already a task. So, and the task inside holds a thread pool task. So we will associate it with the thread pool, and we will execute the work callback on the thread pool and the callback on the event loop after the work is finished. How are we going to do that? So let's fill all the holes in the switch statements here. So we have a loop work, and so we need to have an active loop work. Yeah, we have a loop work case also here, and I will make also the same. So you see, there is a lot of repetition, but it's just because the structure of the library makes it really easy to add another type of async object, because everything is already set up such that you will get errors if you don't handle a specific object type. Of course, this list of loop works doesn't exist. We need to track it, so we are tracking all of the loop work objects into a linked list, actually a double linked list. Of course, we are getting errors in our fancy compiler firewall, manual compiler firewall, where I'm setting the size of the private internal object that is declared as an opaque object, so I don't need to include too many things in the header, and this is all for compile time. Yeah, this needs to be changed, I guess. So you see, it's important using static cast, because, you know, my copy and paste, if this was an interpret cast, would have just been fine. But thankfully, I've been using static cast, and this is being flagged as an error. So make sure to only use reinterpret cast, you know, very, very sparingly, and just, you know, when it's needed. So now I have my loop work object. I think I need to create a sample for it and implement the start function. So async loop work. Maybe let's implement the start function first. So let's say here async loop, let's say wake up start, and we add an async loop work just after. Yeah, what should I be doing here? I will need to queue the submission. I can just return queue submission ThreadPool. Oh, can I even spell ThreadPool? ThreadPool and task. Task is part of the AsyncLoopWork. It's this guy. So we simply pass it in and use it parameter event loop. All right. No, AsyncTask. Let's add the new task. Always add the new task, especially for this kind of, involved library. So if tasks section, I want to make it like this because I think I should be moving this to be not inside the class, just like some of the other files, but sorry, not inside the not inside the class definition. I want to put it outside. So I will not continue this bad habit with this new addition of the loop work. So yeah, I can just say void loop work, and I can implement it down here. Where is it? Yeah, I don't like them being here. I will move them in some of the next commits. So let's do sc async test loop work. So I want to create a thread pool, and I want to put some threads on it. So I'll just create it with num threads. How many threads do we want to create for the test? I don't know. 4. Static context num threads equals 4. Then I would like to create an async loop works to be, I don't know, num threads times num threads. 16 would be in this case. I definitely need to create an event loop or event loop create, and I will run the event loop. What should I do now? I want to schedule the works. So idx, let's say, is the total number of works idx equals, we have to set the work callback. So this is the callback that is executed on the ThreadPool thread, that has for sure to be, we have to be careful because this is running on potentially different threads. So even to just count how many times this is called, we need an atomic variable. Atomic int num works, I don't know, num works. So we can do a fetch add 1. Yeah, And then we have the after callback, which is it's just called callback, that will receive an AsyncLoopWork result, which is empty. But, you know, for symmetry with all of the other Sane C++ libraries, callbacks will just make it accept a result. I think I can even not specify it, maybe. Or not. No, probably not. Void block should not return a value. Why? Maybe is the callback. Oh no, sorry. It's the work callback that needs to return a result. Yeah, sorry, I inverted the two. So this one should be returning a result. This one should not. So this one can just be num callback called. Can just be incrementing the num callback called, because this is running on event loop thread. This is running on a random thread. And we can expect that the number of callbacks called is now equals to, it should be called at least once for every loop work, and even the num works, which we need to load because it's an atomic variable, should be returning the same number of should be incremented the same number of times. So maybe let's make this integer so we don't have problems with conversions. Why do we have problem with result? Which one is not being? No conversion from result to async. Oh, I think I know what's going on. Yeah, we are using result also here, so this thinks that we are using this result object, but we want to return an actual SC result. All right. Will it work? Let's try it. Fail. Num works. How many works? 0. Yeah, we have not been implementing the mechanism. So we need now, but is the num callback called the correct number? No, not even that. All right, so how do we make this to work? I think we need in the place where the async task is being scheduled, which is the same place we are scheduling the here, basically in the activate async phase. If we have an async task, this is getting executed here on the ThreadPool operation. So we are filling the task function and queuing it on the ThreadPool. And this is templatized, it's a template function, and we are calling kernel queue execute operation. So it's here that we need to invoke the work callback inside of this thing. And the easiest way would be for each implementation of the kernel queue to have a result. So let's add a new section. This will be work result. We need to do an execute operation, which has this signature here. Let's do async work. We don't need the completion data, and we can just return async.work And that's it. Should be arriving here. No. All right. Because we are not scheduling the work by calling the start event loop ThreadPool. Now we should be arriving. No. Why is this not? What are we doing here? Are we queuing a submission? So ThreadPool, we are queuing the submission. And this looks fine. This looks fine. Why are we not getting anything? Not even the callback called. No, the callback called is actually called. So this is correct. So the issue is in the actual place where basically we are not getting this, yeah, the execute operation called. Why is it like that? Let's figure out. So when we arrive here, we are getting the generic one, not the proper. Oh, because the signature doesn't match. Yes, I have an AsyncLoopWork and a completion data from async file read, and so the templated version takes precedence. Let's see if now this is working. Yes. All right. Let's run it. Can I just continue execution? Yes. Yes, it works. Yeah. Very, very good. It works, guys and ladies. Yeah. I don't know what to do. So this is now really good. Let's recap what has been done. I have been creating this loopwork object, AsyncLoopWork object that allows you to schedule some work. Let's just put a breakpoint here just to see. We are on thread number 2. As you can see, that is started from the worker threads in the thread pool. And instead, when we get and you see this other task is getting called on the thread number 3, thread 2, thread 1, so all random threads. While this one is called on the main thread, which, you know, every time I say the main thread, not everyone agrees with the definition. What is the main thread? It's more correct to say the event loop thread. It's the thread where you're calling event loop run, because you can technically run an event loop even on a secondary thread, so that will not be the main thread, but it's the event loop thread. In our case, as this is a simple test, the event loop thread is the main thread, which is the literal main dash thread of in this case, macOS, which is the initial thread, the main thread that gets spawned when a process is started. So the callback is called every time after the work has been finished. So this is what you can use to execute some sort of operation in background, and when the operation is done, to collect the results and put it, display it to the user. Because if you make the event loop run, let's say embedded inside a GUI event loop, then you can literally access GUI objects here and update some label and say, hey, the work has been done, and so display it to the user. I think this ends our video for today. I hope you enjoyed the video. So make sure to subscribe if you like what you have seen. Make sure to join our Discord if you like to discuss anything regarding Sane C++ libraries, or even in general every project that is doing Sane platform abstraction in possibly in C++. That's what we like to discuss in the Discord, or even a little bit of C. And enjoy and have fun. See you next time with Sane C++ libraries. Bye.